Hi guys, let's look at the first chapter of your class 9 syllabus, rational and irrational number. You've done most of it in the previous years. Let's quickly revise what we already know. So we have real numbers which are of two kinds, rational numbers which are denoted by Q and irrational numbers which are denoted by Q bar, and real numbers are denoted by R. Now, rational numbers are of two types, which are integers or non-integers. Integers are denoted by I or Z, and non-integers or non-integral rational numbers would be, let's say, 3 upon 5, 2, 3 upon 7, negative 1 upon 4. Those are the negative non-integers, or rather non-integers. Integers would be negative 3, negative 2, 1, 3. Integers are of three types: negative integers, which is basically all numbers which are negative, 0, and positive integers, which are also known as natural numbers. For example, 2, 3, 17. These are denoted by n. 0 and positive integers put together are known as whole numbers, which is also denoted by the letter W. So these are basically what we know. Imaginary numbers and real numbers. So any number which is imaginary, for example, the root of a negative number is an imaginary number, because you can never get you cannot never get find the root of a negative number. So these are imaginary numbers. Now, what are rational numbers? Rational numbers are numbers which can be written in the form of p by q, where there are certain conditions. Condition 1, q is not equal to 0, so the denominator is not equal to 0. P and q are both integers, and the last one is no common element, no element or no common factor between p and q. So these are three conditions. Condition 1, the denominator is not equal to 0. Condition 2, both the numerator and denominator are integers. And condition 3, there is no common factor between numerator and denominator. So let's look at a few more things before we solve questions from the first exercise. So we talked about two rational numbers are equal only if a into d is equal to b into c. What does it mean? It means if I have a upon b as my first rational number and I have c upon d as my second rational number, they are equal only if a into d, which is cross multiplication, is equal to b into c. Let's look at real examples. So if I have 3 upon 5 is equal to 6 upon 10, because basically this is also 3 upon 5. So let's do the cross multiplication. So what we get is 3 into 10 should be equal to 6 into 5. 30 is equal to 30. Yes, so only if cross multiplication is equal, only then the rational numbers are equal. How do you figure out which one is bigger? Well, if a upon b is more than c upon d, then it would mean that a multiplied with d is more than c multiplied with b. So again, cross multiplication, whatever is the sign between them, that remains whole. That holds good. Next part, how do you insert rational numbers between given rational numbers? We have done this, so let's look at certain examples. So if you need to insert one rational number between, let's say, 1 by 2 and 1 by 3, what you do is add the numerator at the denominator, which is 1 plus 1, 2 plus 3, which is equal to 2 upon 5. So 1 upon 2, 2 upon 5, and 1 upon 3. This rational number is between these two rational numbers. The sum of two rational numbers is always rational. Difference between two rational numbers is always rational. Multiplication of two rational numbers and division of two rational numbers are always rationals. Let's look at a few more things, which is what are terminating decimals. So terminating decimals, for example, 1 upon 8, which is equal to 0.125, 1 upon 4, which is equal to 0.25. These are terminating decimals, which means they get over. There is don't keep on going up to infinity. Non-terminating decimal, for example, 1 upon 3. This is equal to 0.33 and 3 keeps on repeating. Another example, let's say 3 upon 7, which is 0.482, rather 42, 0.428, and it keeps on repeating, or not repeating, keeps on going. So these are non-terminating decimals. What are recurring decimals? Recurring decimals are like 1 by 3 is a recurring decimal, which means it same digit keeps on repeating, or a set of digits keeps on repeating. So for example, 4 upon 9, which is equal to 0.444. This is basically written as 0.4 with a bar on 4. You can also look at 11 upon 30, that would be 0.3666, and 6 keeps on repeating. This can also be written as 0.36 with a bar on the digit which is repeating. So in this case, 6 is getting repeated. So these are certain other properties of rational numbers. Let's look at some questions from the exercise. Okay, so we need to arrange these in the ascending order. Find the difference between the largest and the smallest. So let's first put them in the ascending order. So I know negative numbers would be the smallest. So let's take out the negative numbers separately, and let's take out the positive numbers separately. So we need to figure out between these two positive numbers which one is bigger, and we need to figure out between these two negative numbers which one is smaller. So the LCM here, let's take the LCM. The LCM here is 9. So this number is negative 5 by 9, and this number, if I multiply this with 3 and divide it by 3, this becomes negative 6 by 9. In this case, the LCM of 12 and 18 would be 18 and 12. If I take the LCM, that's 2, 9, 6, 3, 3, 2. So this is 6, 18, 36. So the LCM is 36, which means I multiply this with 3. So this becomes 21. I multiply this with 2, which becomes 22 upon 36. So 21 is less than 22. So the 22 is more than 22 upon 36 is more than 21 upon 36. In this case, the smaller number is the bigger number because of the negative sign. So in this case, negative 5 by 9 is more than negative 6 by 9. So they want us to put it in ascending order. So the ascending order would be negative 6 upon 9 is less than negative 5 upon 9, which is less than 21 upon 36, which is less than 22 upon 36. Now this is still not the final answer because the question is given in different numbers. I have taken an LCM, so let me write it in the number in which it is given. So this is negative 2 upon 3 is less than negative 5 upon 9, less than 21 upon 36 was 7 upon 12, and 22 upon 36 was 11 upon 18. So this is arranging it in ascending order from going to the smaller to the biggest one. Find the difference between the largest and the smallest. So the difference would be 11 by 18 minus negative 2 upon 3, which means 11 by 18 plus 2 upon 3. Let's take the LCM. LCM will be 18. So this is 11 plus, this is 6 times, so this is 12. This is equal to 23 upon 18, which can also be written as 5 upon 18. Express difference as decimal fraction, correct to one decimal place. So I need to find 5 by 18. Let me just divide. I guess I have less space on this page. So 18, 0, decimal, 0 comes here. 18 into 2, that's 36. That's 14 with a 0. Now, if I need to put it up to one decimal place, I need to find the answer up to two decimal places and then round it up to 1. So 18 into 7, that's 7 into 8, 56, that's 126. So 0.27, that's 126, that's 14, which means this is equal to 1.27. If I need to round it off, it will be 1.3. So that's the difference. And then the last concept of this exercise, which is without doing the actual division, you can figure out if a number can be, or if a rational number can be converted into a terminating decimal or not. Now that trick is, if the denominator can be written in the form 2 to the power m multiplied with 5 to the power n, then it is a terminating decimal. If the denominator cannot be written in the form 2 to the power m into 5 to the power n, it is non-terminating. Let's look at an example. So we did the example of 1 upon 4 is equal to 0.25. So this is a terminating decimal. My denominator can be written as 2 to the power 2 multiplied with 5 to the power 0, because any number traced to the power 0 is 1. Since this can be written in the form 2 to the power m multiplied with 5 to the power n, therefore it is terminating. Right? So now let's look at this. 7 by 16. 16 can be written as 2 to the power 4 multiplied with 5 to the power 0. So therefore 7 upon 16 is terminating. Let's look at the next part. Next part is 32 upon 45. So denominator is 45. 45 can be written as 3 into 15 with the 3 square, 9 into 5. Right? Since it cannot be written in the form 2 to the power m multiplied with 5 to the power n, therefore 32 upon 45 is non-terminating. Let's look at the next one, 40. 40 can be written as 8 into 5, which means 2 cube into 5 to the power 1. Therefore 17 upon 40 is terminating. And let's look at the last question here. 75 can be written as 3 into 25. Yes, so that's 3 to the power 1 multiplied with 5 square. Therefore, it is non-terminating. It is terminating only if the denominator can be written in the form 2 to the power m multiplied with 5 to the power n. Thank you so much. Take care. I'll see you with the next video. Bye-bye.